Today's topic is numerical on moment of inertia. This is fourth numerical on moment of inertia. Numerical is determine moment of inertia of a section shown in figure about horizontal centroidal axis. See this T section. Dimensions of T section: top side flange width is 200 mm, flange thickness is 20 mm, wave height is 200 mm, and thickness of wave is 20 mm. And determine moment of inertia about horizontal centroidal axis. That means about this axis. And horizontal centroidal axis is x-axis axis. For solving moment of inertia about x-axis axis, that means for solving Ixx, divide this T beam into two parts. First, this is flange part, and second, this wave part. So I divide this wave and flange here. And this flange centroid is x1 x1. Give name x1 x1 axis, and this wave part centroid is x2 x2. So about this x axis, difference in this x axis and x2 axis is this x centroid axis is for this whole T section, and this x2 centroid axis is only for this rectangular wave part. So this is 1 A1. Area of this flange part is width into thickness, that means 200 mm multiplied by 20 mm, that means 4000 mm square is area of this rectangular part, first rectangular part. And this second, for this second rectangular part A2, area is, see here, thickness is 20 mm and height is 200 mm, that means 200 into 20, 4000 mm square. Both A1 and A2 areas are same. Now from bottom, from this side, centroid for this first part, that means y1, is centroid from bottom here. See, from this side to centroid of first part, that means to x1 axis distance is this 200 plus 20 by 2, 200 plus 20 by 2, that means 210 mm. And for y2, For y2, distance from this bottom part to centroid of this 2 that means up to this distance, it means 200 by 2. Hundred mm. Now find exact centroid for this section. This A1 is area of this first rectangle, A2 is area of this second rectangle, Y1 is centroid for this first rectangle, and Y2 is centroid distance from bottom for this second rectangle. And Y1 is also centroid distance from bottom to this first rectangle. Now for this T section, what is centroidal distance from bottom? For solving this, use formula y bar is equal to a1 y1 plus a2 y2 upon a1 plus y1 a1 plus a2 sorry a1 plus a2. A1 is this 4000 multiply by y1 is 210 plus a2 is also 4000 and y2 is 100 divided by a1 plus a2 4000 plus 4000 y bar is equal to, so 4000 into 210 plus 4000 into 100 divided by 8000 is 155 mm. That means this 155 mm is this distance from bottom to this x-axis distance is y bar and it is 155 mm. So we have to calculate this moment of inertia about horizontal axis, that means ix about x-axis. So for calculation of this, ix is equal to I this x1 first part, first rectangle x1 plus I x2 I the first rectangle is for calculation of moment of inertia for this first rectangle is this is a rectangular part, so I x1 is bd cube by 12. So parallel to this x1 axis is this 200 mm side. So 200 multiply by 20 cube divided by 12 moment of inertia for this I x1 200 multiply by 20 cube divided by 12 plus area of this first flange part A1 is 4000 mm square. 4000 multiply by distance between this distance between center centered of flange side to the total T section centered. That means x1 x sorry x axis to x1 axis distance is, what is this distance? So this distance is, see, this distance is 210 and minus y bar, that means this distance 210 minus y bar, and y bar is this 155 mm. We have to calculate this distance, and for calculation of this distance, consider up to from bottom to x1 axis distance, and this distance is this y1 distance 210 mm, this 200 mm plus 20 by 2 210 mm minus y bar is 210 minus 115 210 minus 155 and square of this term, parallel axis theorem, plus second wave part moment of inertia. Wave part moment of inertia is, see here, I x2 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 axis parallel side is this thickness of wave 20 mm, that means 20 as it is multiply by 20 multiply by 200 cube divided by 12, 20 multiply by 200 cube divided by 12 plus A2, area of that wave is also 4000 mm square, multiply by distance between x2 and x axis. So consider this x2 axis lies on 200 by 2, that means 100 mm. So here x2 axis lies, and distance between x2 axis and x axis is y bar minus y2, that means we require this distance, this much distance we require for parallel axis theorem. And for calculation of this distance, see this y bar minus 200 by 2, this x2 distance, x2 axis is 200 by 2, this is y2, y bar minus y2, that means y bar is 155 minus 100, 155 minus 100 and square. So we get, so for this T section, moment of inertia about horizontal x axis is 37.66 into 10 raised to 6 mm raised to 4. For this T section, moment of inertia about x-axis axis, that means horizontal centroidal axis, Ix is equal to 37.66 into 10 raised to 6 mm raised to 4.